because there were a lot of questions that were being asked at how everything is going to get gelled up together. I mean, the way the base setting that we are trying to do. We started with Python, and I think there is only one topic which is left, which was Plotly. We'll uh, handle that too. After Python, we were supposed to get into data side, and then eventually get into uh, the machine learning, deep learning, and agentic AI. Uh, but I think it's important that you also understand that how everything that we are doing at the base level, right, how it is going to get converged. So I thought, let me give you a brief understanding of how machine learning works, so that you have a better appreciation, you have a better sense of the different modules that we are learning, right, and how they are going to gel up together, and so that you also are very committed learning them and ensuring that uh, to an extent where the machine learning requirements are met, right, you're taking your understanding, you're taking your skill, you're upgrading yourself till that level. I think some kind of rigor will be required at your end as well. So I thought, let me have a quick conversation about machine learning, talk about the concept, uh, talk about the algorithms, and then also give you an understanding how a machine learning problem is actually kind of solved. Right? So it's a kind of a brief overview of how things work, right? But it is only a brief one. So we are actually supposed to get back to this topic in with much more momentum, and also we will be better equipped when we reach here. So with that, let me share my screen. I hope you can see my screen.
Yes, absolutely.
So in today's session, I'll only be covering data. I will cover machine learning overview and supervised learning, the three topics at the top. And in fact, it is largely on the machine learning and supervised learning. Uh, so data, I think we all understand, but uh, it's important that you also realize, and the fact that we discussed in the first session, that what actually has contributed to the current wave of AI, and one of the element is data. So we all know that ever since mobile came into being, the data is getting generated at a very rapid pace, right? And apart from mobile, right, there are many more sources of information. IoT, cloud platforms. I think the way the hyperscalers are working now, everything, and whether it is your websites or the products, right? I'm referring to the software products, right? They're getting hosted on different cloud platforms. We are getting away from a model where things were getting installed on your systems, right? Even if it is an app that is getting installed, the larger system is still sitting on cloud, right? And web scraping now, because of the LLMs, we also understand that, okay, how important the web scraping is. Traditionally, these have been used by the marketers to understand what is happening with the competition. That's one. Second, also to understand how they can actually optimize their SEO engine, right? And social media, I think we are pretty much aware that how the social media is exploiting the data, and also that it is generating so much. Consumer transactions, what is happening in the e-commerce is just amazing. Right? A lot of data is getting generated again from app usage, geolocation data, whether it is coming on map or some other app, right? And yes, of course, there is a lot of research which is happening. In fact, if you go back into if you go back a few years only, in 2017, there was a study. The paper was submitted on transformers, right? I'm referring to transformers in context of machine learning, deep learning, right? And that actually was the seed, the foundation for ChatGPT. So 2017 and 2018 something, OpenAI was ready with the version first. I think they released the public version maybe around 2020, but this paper actually kind of expedited how the LLMs, how the generative AI actually can take place. Anyways, we will talk about once we reach there. Then yes, there is satellite related data. I'm yet to come across this kind of data set where we try to understand how this can be used. Apart from the GPS, I mean the geolocation, in case if it is getting tagged through a map or something of that service, right? I think I'm good. But in case if those services are not available, maybe we have to rely on satellite data, right? And then of course, a lot of data which is getting generated in the healthcare industry around your biometric and all these apps, these smartphones. Now they have devices that can actually monitor your basic health indicators. So a lot of data is getting generated, and uh, these data pockets are very important when it comes to machine learning. Right? Machine learning will be powerful only if it has got sufficient data, variety of data, right, and quality of data. Otherwise, you may, in case if the quality of data is kind of compromised, you will be able to create models, but the accuracy, the output will be a challenge. So now let me take you to the next slide. What is machine learning? I think we all understand that when a machine kind of it produces intelligence which is equivalent to a human, the way we think, the way we take decisions, right? That is what you can assume that it is machine learning. Now, machine that can learn and take decisions explicitly, those things are not coded. Otherwise, when you write a code, it's a rule-based system, if else construct, loops, right? Now here you don't do that. You let the machine take a decision based on the data and the pattern it is looking into the data, right? And that's where some of these implementation come into the picture. The bot detection. In case if a bot is coming on your website, right? You know how it actually has to be detected. Though there will always be some other mechanism that will come from the bot side, right? They try to get into your system, but still you need to upgrade. But the model will be such that you are trying to identify whether it's a human who is coming onto your website or it's a bot. Uh, then the recommendation. I think recommendation is a very solid case study which we have already discussed, right? Based on the patterns, based on the usage, there are different recommendations. Then the intent. I think in the last 2-3 years, this is one of the solid progress which IT industry has done, our AI industry has done, wherein more and more context, more and more intent. I mean that kind of effort is being done. So in case if you go on to Google even now, they also have learned from OpenAI. Uh, in case if you ask certain questions, they will try to understand what is the intent, right? And of course, it is far better in OpenAI. Definitely, it is leading the entire set of tools that are available as of now. So intent recognition is something which is done using machine learning, right? And then object detection. So they have got their own usages. This definition I have picked up from Wikipedia. It talks about that the you build methods that can learn on its own. Right? I'm sure that you understand this as much as I. Now, the machine learning can be divided into further categories. We have supervised learning, we have unsupervised learning, and then we have got reinforcement learning. We will not go deeper into reinforcement learning um, unless until there is a clear-cut use case which we were trying to make work. But otherwise, at least in these sessions, we will talk about supervised learning, unsupervised learning, and from there we will go into deep learning. But a quick one, supervised learning is where you have got you have a data set, you have got different columns. I mean, since we understand the language of what is table, what are rows, columns, right? So there are some columns uh, that are actually kind of contributing to the output, and there is an output column as well. So now in machine learning language, those columns which are kind of influencing the output, those columns are called as features, and the one which is getting predicted is called as label. So in supervised learning, we have got features and the labels are also defined. So in a way, in supervised learning, you know what you are going to predict. Very clear and very straightforward. Example, maybe the dropout ratio, whether a particular student will pass, fail, something of that sort, whether the student will continue uh, uh, in school, college. So, I mean, if you are building those kind of models, there are features and there are labels on top of it, right? Unsupervised learning is a stream where you have examples, you have features, but you really don't have an output uh, column. I mean, there is no label as such. So you're not really predicting, and that particular column. Let me explain this with an example so that it is much clearer to you. Uh, but continuing this particular slide, reinforcement learning is a place where it's kind of a stream where you build an algorithm, it takes certain actions, and then you either reward or you penalize. So typically, in when you are talking about autonomous vehicles, the way they have been trained, they will take a step, and the algorithm will assess, the system will assess whether that step was taken up, was in the right direction, right? In case if it was taken up in the right direction, they will encourage further by rewarding that action. In case it was actually a mistake, say the you're training a vehicle and it hit a wall, so that was not the intended action. So in that I mean that particular action will be penalized. So this is how the reinforcement learning works. A lot of gaming sites are also using reinforcement learning, right? And of course autonomous vehicles, they are heavily leveraging reinforcement learning. But just in case if we have got a wonderful case where we can go ahead and try to implement reinforcement learning, Can you hear me now?
Yes, sir, you are audible.
I'm
Yes.
so sorry, my system again collapsed. Not sure whether there was a patch that came in the morning that is causing the trouble. I am sorry for this. Give me a moment and let me bring up the PowerPoint deck again. And it took me a while to realize that my system is stuck. So I was kind of already in a monologue. So you have to help me understand where actually I was. And I hope the recording is still on. No, got stopped. Oh, it's still done. Great. Okay. So can somebody help me? Till what point did you hear? I was talking about reinforcement learning. Did you hear what I was sharing? Sumit?
Yes, sir. Sir, basically, when till the time I was able to hear you, we were in unsurprised learning only. Supervised learning.
Answer. Okay, okay, sure.
Yes.
So I was referring that most of the things that we are supposed to do should get covered in supervised and supervised learning.
Yes.
And in case if you have got a wonderful use case on reinforcement learning, you guys can bring it up. But it is more when it comes to dealing with materials, and this is where the reinforcement and learning comes into the picture. I was referring to the autonomous vehicle, where uh, every action that the algorithm takes or the software takes, there is a reward and penalty associated with it. So in a way, a good action is encouraged and a bad action is discouraged, right? And this is how the autonomous vehicle actually have been trained. All right, so let's go ahead into the next slide. Yeah. So I spoke about that we have supervised learning and unsupervised learning. And in supervised learning, sorry for that. Yeah, in supervised learning, we have got labeled data, right? The column that we want to predict, right? And then we have got features, we have got different algorithms that can be applied. So it is very well known when you are applying a particular algorithm, what is that you are trying to predict? It is very well known to you. So the problem statement is very well defined. It's uh, a representation of how the input data will be fetched. Then you will have some kind of training data, you will have some kind of desired output. Desired output is nothing but the label. Right? You will apply some algorithms. Right? There will be some processing that will take place and there will be some output. So on a very high level, this is how supervised learning works. So you feed the data is split into training and we will talk about it, training and test set, right? And prior to that, you identify, okay, what all columns needs to participate. What are the different data sets that you will bring in? So, and this is a very complex task. It's not that you will bring one table. From the understanding point, we will pick up examples where we are talking about one particular entity or one particular data, one particular table, right? But in the real world, it will be far more complicated. You have to bring data from different dimensions, from different sources, join them together, right, and then take a decision. So this is an example where what we are trying to do is to predict the final exam score, and this is a label, right? And the different inputs, how many study hours, what was the attendance of the student in the school or college, right? What is the track record? So all these features are available. So when we are trying to create a model, we will assess how much they are actually contributing to the final exam score. And please do make a note. that when you're dealing with uh, machine learning, it is the prediction machine learning will do. They actually do not do, they do not will not create a mathematical formula. So they will not say that x is equal to y square, something of that sort. That means that there is a mathematical equation that exists between the two different variables. Machine learning is not required in such cases, right? So machine learning will talk about the possibilities. It will talk about the hypothesis that maybe this is the kind of relationship they see between multiple between two variables, right? So maybe when you would have studied about correlation in schools and colleges, I'm not sure in BTech they make you learn correlation, but yes, in school definitely it is there. So the correlation is all about how one particular variable impacts the other one. It can be inversely proportional, it can be directly proportional, something of that sort, but there is a relationship. Even there is a negative relationship is also a relationship. So when we are picking up the different features, we try to relate how they are actually impacting the final output. So study hours, attendance, pass grades, exam scores, right? Sorry, exam score is somewhat impacted because of these different features, and that's what your intention would be, that you create a model that can help you predict uh, what will be the score of a particular student. So let's go into the next one. This is more about the email detection, right? Where a very typical one, where you're detecting whether an email which is coming into the system, whether it is a spam or it is a genuine email, right? So there are different columns here again, uh, and some kind of data or text analytics already has been done. So here, what we are trying to see is that whether there is any word by the name free. If this particular word is appearing in the email, right? It is saying yes or it is saying no. So 0 and 1 are that this is how it has been qualified. Then whether the domain name is in the senders list. So people who are using Outlook, uh, uh, their whatever emails that are coming from a creditable uh, domain, right? Uh, it is Outlook keeps a track of it. Most of the times it is the internal communication that is being measured, but then there are external conversation as well with customers, with different stakeholders, right? And that's where uh, the familiarity of the domain name, it's talking about whether it is known to Outlook or not. Then if it contains some kind of links, in case if there is a link to a file, link to a website and so on, and based on that it is actually predicting whether the email which has come into your inbox, whether it is a spam or not. So this is another example how this is another example to represent how the supervised learning is taking place. Now, supervised learning also is of two different types, and uh, the one is regression, another is classification. When you're dealing with continuous numerical value, when you're dealing with continuous numerical value, this is where the regression techniques comes into the picture. So in case if you are predicting a number, right? Say if you are predicting a BMI of an individual, or maybe the temperature, when you're doing weather forecast, it is actually a regression one. Right? So here again, the goal is to find the relationship between the inputs, which are features and output, and predict future values. So in case if we are predicting what will be the revenue of a company, or maybe what will be the profit margin, so all those things comes into the category of regression. And when it is about classification, you are trying to predict the different classes. So it is not the numbers. So in that case, what you are, uh, yeah. Was there a problem with the link in between? I see that a lot of people who actually had joined, they are rejoining. So any kind of disruption happened?
No, sir.
Okay. Sure. I just want to make sure that uh, there is nothing which we are missing. So in classification, we try to predict the different category, or we have different label classes in the labels. Yeah. Okay. So here, maybe when you are trying to predict whether a disease diagnosis is done, whether it is positive, negative, it is a classification. If there is an image which you're trying to recognize whether it is a cat, dog, and birds, right? Again, it's a classification one. So the output is very discrete. It is not continuous, right? Regression has got numbers, which is kind of continuous, whereas classification has got very clear understanding that there are classes that you are going to define, right? And the name is also is such. So this is a graphical representation of a pictorial representation of how these two different techniques look like. So if you see classification, very clearly differentiating between the two different categories. This is different, right? So maybe this is A and B. So when you are giving some kind of input, uh, uh, or maybe you are giving some features, right? And the algorithm will identify whether it is A or it is B, right? Whereas if you look at the regression one, these are the different data points, and this line will get further extended, right? So there can be some points here, there can be some points here, and so on. So that is why it is termed as continuous. Any problem statement that you will work on time series, it is going to be a regression one. It is going to be a continuous numbers that you are going to predict. So if we go back to the examples that we discussed in the beginning, so here what we were trying to do, predict the final exam score, right? And the score is how much? 50, 60, 68, something of that sort. So there is it's not a class, right? There are no classes defined here. We have got continuous set of numbers, and this is why it is yeah. I think probably have to change some settings in the way the the lobby is working. Maybe I don't have to allow. It should be auto edit to the meeting. So I mean, dropping and drop out is kind of impacting the flow. Okay. Anyways, so in supervised learning, we have got continuous set of variables, set of numbers, and this is an example where we have got 50, 60, 68, and so on, right? So this is a regression, and then spam detection is getting into the category of classification, because it's a yes and no. Very clearly, yes is one category, no is another category. Right? So this is a classification. So there are, and it is very important for you to understand when you are you have a data in your hand, and whether it is going to be a regression technique that you are going to deploy, or it is going to be a classification technique that you are going to deploy. And some of the examples of popular algorithms are also called out here. Right? Linear regression, decision tree regression. So this is in the regression form, and then we have got logistic regression, decision tree, Nye base, random forest. All these are classification techniques. Yeah. So this is where we have specified different use cases. Here, what we are trying to do, we are trying to predict what should be the price of a commodity or price of a house. When you're defining the price of a house, if you are doing this prediction, the price of the house will be in some numbers. So it's a regression one, right? And maybe these are the different features. What is the size of the house? How many number of bedrooms are there? What is the location? Right? And I think some of these, and you can figure out, you can find these different data sets which are available on Kaggle, but they're confining to US as a region. And so there are some parameters, there are some aspects that we need to take into consideration. In fact, I have the data set with me, so we'll look into those details. And there is an example that we are going to work upon. In any case, so we will go into the data side of this particular use case. Then here, what we are trying to predict is the resale value of a particular vehicle. So what is the overall age, annual mileage, brand score? Again, the resale value is going to be a continuous set of numbers. So it is a regression, right? Then we have study hours. This is already we have discussed, right? Final exam score. So it's a regression one. Now let's look at the classification one. Age, income, debt ratio, right? Whether the loan should be approved or not. It's a very classic case. And though very general, in a way uh, is used very extensively. Nevertheless, I think there is a lot of work which is being done on the loan approved algorithms. So there's a lot of documentation available, a lot of data available, so you can experiment and build models. But again, here there is a classification which is happening, whether the loan will be approved or not. So we are not talking about how much loan will be approved. The moment we bring how much loan, that is going to be regression one, right? Then we spoke about span. This is already discussed. And then we have a lot of data which you will find on from iris. So iris is one of the data sets that you will find. Iris, right? Even the algorithms, the module that we are going to use, it actually has got iris data embedded into it. So iris data typically talks about how will you identify a particular flower, right? There are different flowers that have been mentioned in that. I think there are 4 different categories, and based on the petal length, petal width, right? Sorry, I don't come from a biological background. I mean, I did not I did not had medical in 11th and 12th. I had engineering drawing, so I'm not very well acquainted with these facts. Maybe somebody who had medical in their 11th, 12th, they will be able to understand this and appreciate more. But based on some of these parameters, the classification is done, right? So again, it's a classification technique, and the different examples based on the kind of problem statement that you are facing, right? You're trying to solve, right? There are different algorithms which have been listed here. You can look into these algorithms, name of these algorithms. If you are very interested, you can actually go into the details, study a bit. But this will definitely enhance your understanding of what is happening in the ML world. What are the different techniques which are very popular, right? And in case if you can spend some time, your understanding of the overall subject will improve. Okay, so yeah, so I can take a pause here and take up questions if you have any. So in a way, we have established what is supervised learning, what is regression, what is classification, and we have gone through different examples, how you have to categorize whether it is a regression or classification. So I mean, this is what we have covered up till now. And before we go to the next step, let's talk about if you have any questions that you want me to address.
Also, there's one question like in the reinforcement learning, right? Do we also have features or labels kind of thing in the test data or whatever input data we pass?
See, the data definitely is there, Vishu, but uh, it doesn't work that the way that we actually have defined in supervised and unsupervised learning. Supervised learning and unsupervised, in terms of complexity, they are far more simpler. So the data in reinforcement learning will also be there, because in case if you're talking about autonomous vehicles, there can be a lot of environment related stuff that you will be taking into consideration. What is the speed, what kind of surface it is, and so on, right? And based on that, okay, what is the block that you have identified, right? In case if you try to prevent it, what were those prevention steps that were taken up, right? So the data will be there, right? But it is more about the action, and then there will be retrospection that will be done. I hope
Okay,
you're getting
so
me.
yeah, so the output of that reinforcement learning will be an action item. I mean, there can be multiple action items as a part of that output.
Uh, See, so the way the theory works, because I have not
Mhm.
seen reinforcement learning in action as well. So that the way the
Okay.
theory works is that all you do in the system, you actually reward and penalize that particular step. So you will say, that, okay, I am giving -10 to this particular step, or I am giving +10 to this step. And when you take it back to the system and retrain your model, that
Mhm.
reward and risk will have a corresponding action. So either it will discourage that step that was taken, or that step will be encouraged. I mean, one of these activity will take place, or maybe it is. I mean, yeah, these are the two different actions that will take place. So there's a lot of retrospection that is happening in reinforcement. I did A, B, C, and A is okay, B is good, C is not. It's not a great option. So C will actually be kind of taken off from the set of actions that you are working on. A and B will be assessed, right? And then further, in case if depending on what actually has happened beyond B, maybe B delta, A delta, right? Depending on that, the next steps will be formed.
Okay, so are we going to feed this what you say the action items again to the model or the retro part, or it will be a different subsequent subset of the model?
No, so here the model is continuously trained.
Okay, so we change the data input data for the reward
We
and
we
yeah.
correct, correct,
Okay,
correct.
okay, got it. Sir.
But Vishu, I wanted to understand from you, is there a use case with you where reinforcement learning, are you visualizing something into the automation world where this can be actually leveraged?
Not exactly. It is like analyzing the logs and auto fixing the failures.
Can it be leveraged in RPS?
RPS in the sense.
Sorry, remote procedure automation.
I'm not sure. I need
Okay,
to
okay,
get more in. Yeah.
okay, okay. All right, okay. So yeah, any other question that we have? All right, okay. So if that is the case, then we can move
So
on to the next step.
currently,
Yeah. Yes, Amit.
currently, I am not able to visualize any other real life example where I can relate. So can you please help me with that?
Which one you're referring to?
So reinfo, info.
So yeah, I I would suggest that let's pause um, the effort on reinforcement, right? The only thing that I can, and my experience on reinforcement learning is also very limited, right? I have not seen a single implementation. Theoretically, we were trying to design a system that will actually collect the balls. I mean, you have ball collectors now, right?
Yes.
So some 7 8 years back, we were trying to build that machine where if it is deployed on onto a particular ground, right? Maybe a tennis ground, it will go ahead and collect all the ball on its own, right? So when we were trying to do that, that was a time when we realized that okay, uh, uh, the ball collector will work on reinforcement learning. So first of all, and it is so since I'm bringing this up, I let me share the kind of challenges that we had. So first of all, it is difficult to identify a ball, right? And tennis balls are typically green in color, right? And if it is a grass court, it is difficult to identify whether it is a grass or it's actually ball. If it is a collection of ball, right? How the system is able to identify. So in a way, what will happen? Not only the ball collector will move around in the ground, right, and try to handle all the kind of challenges it will have. It should not get into the main arena where the players are playing, right? It should not cause any disturbance. It should collect the ball from non prime areas, right? Maybe the corners and all, right? So, and when it is reaching out to the corner, it should not hit a wall, right? It should not hit any other object. It should not hit humans. So every time all these kind of things which are happening, right, it will actually kind of penalize or it will reward. Now that particular system remained in the design only. So we could not take it to the production. So that's where I'm saying that okay, I think I attempted that, but we were not able to build the machine as such that can actually collect the balls. It because it was more on the material side, less on the software side. Sumit, and
Okay.
I think one more. I think what I can also do, I can spend some time because this is something which I have not also researched enough. Uh, I can figure it out if the gaming platforms are using reinforcement learning. I have heard about it, but I have not gone in depth. So maybe if you are working on Xbox, uh, there is a possibility. Maybe the reinforcement learning is being deployed when you are trying to create some kind of simulations.
Sir, but can we take an example of the automated bowling machine which is used in the cricket field to for the batsman? So, considering that as an example, can we use that in as a reinforcement thing? Like that is also
Hmm.
predicting a person, predicting the where we have to pitch the ball, considering the speed of the ball and all these things.
Well, I'm being tempted to say yes. So, but I have really do not know. I think it's a good example. Uh, but lot many times the way at least the way I have seen it is it's a very mathematical thing. You define in on the machine there are parameters which are available as far as I have seen, right, in the demos. What will be the speed? What where the ball will pitch, right, and how much the bounce is actually driven by the ground. But
Yes.
these are the factors which are kind of given in the machine itself. So all it will do, it will throw the ball at a particular speed. I think so. So there is no learning happening here. In case if it is autonomous, then it's a different thing. So the most of the times, what I have seen is that the batting coach or maybe the bowler coach, right, somebody will be feeding the ball with the machine with the different balls, and they will be applying okay what kind of ball it needs to simulate.
But so that is a semi automated, na? Considering as an upgraded version, we can take an example here. where everything will be monitored by the with respect to the movement of the batsman, or with respect to the position of the batsman. Everything, every decision will be taken by the machine only, and that will keep on enhancing to with respect to the uh, skill of the batsman, where how that the batsman is playing the shots, and how
Yeah,
that he is handling the balls.
yeah. I think we can actually take up the system to a level uh, where risk and reward can come into the picture. In case if you say that okay, no matter what, the machine should simulate balls. It should simulate in a way that when the batsman is playing, the avoid is that the batsman is not able to hit, or maybe the batsman gets bowled out,
Yes.
right? So if we are bringing that kind of intelligence, that means that okay, all these parameters, including the surface level details, right? Maybe
Yes.
it will take some time, and it will be getting trained, auto trained after every action. So uh, theoretically, it is possible, and I mean, this is all I can say as of now. You have taken the direction, taken the conversation to that direction where I'm getting tempted to say yes, it is possible. It will be
Yeah.
a reinforcement learning in that case, Sumit.
Okay.
So I think you can spend some more time. And in any case, spoke about gaming. So I can also spend some time. And I know that though we were not supposed to talk about reinforcement learning, but the entire conversation has gone into that direction. Uh,
Yes. Most of
Nevertheless,
the
I think this,
examples were taking toward that only thing.
yeah. I think it's a learning for us, right? How we are differentiating and how we are actually working on different problem statements that we have in hand, and trying to figure out what could be the possible action. So I think it's a good conversation. Uh, we'll try to come, maybe in the next conversation. I'll try to come back with my understanding, my research, and Sumit, Vishu, if you also spend some time, and maybe rest of the folks as well, in case if this topic is interesting to you, you can think about it and come back with some kind of response.
Sure.
Yes.
Any other question? Okay. And are you finding this relevant, easy to understand? Am I going too fast? Is it too heavy on you?
No, no, no.
All right. Thank you, Sohail. So let me go back to the slides then, and let's talk about the process that is involved. So when you're working on a supervised learning, whether it is classification or regression, there are some steps that makes the overall that forms the overall cycle. So let's talk about those steps. Um, so it actually starts with a problem definition, and this is where the business, or maybe somebody, the way we were discussing just a while back, that okay, maybe the uh, what should be the name of the machine, but it is used in the practices in the nets when the batters are actually practicing before the matches, right? So we defined that okay, what kind of parameters it will take. Should it be uh, semi-automated or fully automated, right? And should learn from the environment, right? All those parameters. So if you're defining, you have to define the use case accordingly. This is very important because the more we spend time here, uh, there are a lot of questions that will come onto the surface. Otherwise, you go into the process, you go into the execution side, or maybe you have produced an ML model, right, which is not yielding good results, and you kind of get into a notion that okay, machine learning is actually it's a hype, but it is not delivering what it is anticipated to do. So actually, the problem starts from this place itself. The problem is not defined well, right? And as a data scientist, the moment you are getting such kind of problems or the use case statements, right, your thoughts will also start kicking. So you will start thinking that, okay, maybe this is the use case which is given, which is defined in these different dimensions. What kind of data that you will require? What kind of challenges that you will have? You may also ask, what is the threshold of accuracy? How accurate the data should be, and this is very important. Right? I give this example in all my classes that we were in conversation with one of the hospitals in US, and they wanted us to predict the suicidal tendencies of some patients. I mean, it was from the mental health care standpoint. Now, when you're getting into that kind of space, you understand the kind of accuracy that is required. Right? I don't want to qualify it. I was actually kind of shaken up. Even if it is 90%, it is still not good enough. Even if it is 99%, maybe my thoughts were that, okay, it is not good enough. Right? Again, so it is kind of domain centric. But you, as a data scientist, you need to understand, okay, what is the threshold? In case if the hypothesis is 5% off, 10% off, maybe 20% off. Again, depending on where are you, what kind of challenge that you are dealing. Is it the first time that particular problem is getting solved, and so on. So when you are getting this kind of problem statement from your organization, please spend time here. You can definitely go ahead and implement and work on limited information, but that will always have repercussion, that there will be a lot of rework that will happen. So in case your organization and your system is okay with the rework, lot many organizations aren't. But in case if your organization was such, right, where the research is kind of a part of the delivery cycle, and people have that understanding, typically that happens with the startups, you are okay. So I mean, you can start with an abstract statement, and you can further elaborate it once you are into the execution. So this step becomes very important, problem definition. Then you have to gather the data, and gathering of data cannot be simple. It is actually fairly complicated one. And specifically when you're defining, or maybe you're solving a problem statement from scratch, if it is already there, somebody has done some work, right, and you have been deployed either to maintain it, improve it, right, then your take will be different. In case if it is about improvement, all you need to do is to try to understand what all good practices have been implemented, and in case in terms of data, is there a possibility that we can bring some more data set, right? So here if we are, I mean, this example has been given, but look at how trivial it is. The effort is also pretty lame, right? But at organization level, the data gathering is very, very important. Then comes data cleaning and pre-processing. So up till now, I think we have spoken about data gathering. I think this is pretty much known to you. Data cleaning and pre-processing are two different steps, and they have got a lot of value. Your quality of output to a very large extent depends on this. So when you're dealing with data cleaning, it is more about the quality of the data, whether there are duplicates, there are missing values, right? So you have to remove, you have to handle missing values differently. We generally fill, or we either we fill when we say fill, maybe if it is a string, and say so you can say unknown, something of that sort, which is defined in your system, or you can drop that particular row itself if you have got good volume of data, right, and the missing values are very limited. Then any kind of duplicate, because necessarily it will kind of impact the output. Why to have duplication? So it is absolutely must that we remove the duplicates. Now these are the two different techniques: normalization and encoding. And we'll have a specific class to talk about what is normalization and what is encoding. A quick one, normalize is when you are dealing with numbers. Say you have got ABC different columns, and uh, say this is age, right, and this is salary. Let's take two columns only, right? Now age is maybe it's a two digit one, right? Whereas the salary is going in 6 digits per annum kind of thing, right? So when the numbers are so different from each other, they will form a different. They will actually cause a different impact on the model. So generally, what we do, we try to bring it to the same level. And what are the techniques? I will talk about it. And encoding is the place where we convert the categorical data into 0 and 1, true or false, or maybe 1, 2, 3, 4. Again, we will talk about it. I just want to make sure that you understand what is the process cycle. And this is a place where you need to build your muscle. This is very, very important. This is non-negotiable because this is completely onto you. The other two steps which we have spoken, uh, it is more about the ecosystem that you are in. You can go back and say that, okay, the problem statement was not defined well. Okay, people may accept or may not. uh, the other step where you're doing data gathering, you can go back and say that, okay, the data is not good enough, and that is always the case, right? So that's not an issue. But in case if anything that happens here, right, this is some completely in your control, how we are dealing with the data. So this is something which you need to spend time and look into some of the case studies. We will also solve some examples where we will normalize the data, where we bring different encoding techniques. So once the data is clean, pre-processed, right, we divide the data into two different pockets. One is training set, the another is test set. Training is that will help you to train the model, and the test is when you actually use this data to test how good the model that has been generated, right? So you divide generally between in a proportion of 80 and 20. It can be 70-30 as well. Again, as a data scientist, you will figure out, and also based on the data set and the domain you are living in, um, you will figure it out that whether it should be 70-30, 65-25. So you have all the liberty, but it has to be a fair one. It should not be 50-50, right? It has you have to give as much data as possible to the training one, right? So a fair ratio should exist. And once the splitting of data is done, you have to choose an algorithm. So it gets, and this is what we discussed in the previous slides as well. If you are doing a regression, right, there are some popular algorithms. And if you are doing a classification, again, there are some popular algorithms. So I think these days, if you look at it, there are two different algorithms which are very, very popular. Um, Random forest, it consumes a lot of, it is very resource intensive, but the output is fantastic. And then we have got XGBoost. So this is also something which is extensively used in the industry. Uh, when we reach onto the algorithms, how they are actually being built, we will cover at least one of these in the training. So you are choosing an algorithm, right? After splitting the data, then comes you train that model. Uh, you have identified the algorithm. You divide the data into two parts, right? Now you go ahead and train the model using the training data set. Once the training model has been created, then you actually test it, right? And when you test it, you identify whether how whether the how accurate the model is. And for that, to identify the accuracy, there are a lot of indicators that we measure, right? So mean square error is one such, right? Accuracy, precision, recall, F1 score, R square score, all these are techniques to measure the error. So remember that we actually have taken up a hypothesis, right? We assume that okay, there is a relationship exists. So maybe in case if you are doing a regression and you had predicted that the student will score 68, whereas the student scores 74, right? So there is a gap, right? So you will collect this one, and you will collect the data for other students as well, and try to figure it out. Okay, what is a how way off we are from the target. So this is how the model evaluation is done. Again, this is where you have to justify your models to the stakeholders that uh, whether it is 90% accurate, 95% accurate, and so on. Now, again, it is all these things are very domain centric. Um, Let me give you an example, and I think probably I would have discussed with a couple of folks in this forum that we were working for Microsoft, and so there is an annual cycle where the contracts are renewed. Uh, so proactively, and a lot of contracts traditional the way Microsoft financial calendar works, it starts from July to June. So that's how it is spread. Like in India, we have got April from March, April to March, right? Similarly, they have got this kind of calendar. US generally follows January to December. Otherwise, so we created a model, and before the renewal cycle was supposed to kick off, we published that model, right? And that model was around 92-93% accurate. Now you may be tempted to say that wow, what a good work. Actually, that was kind of reception that we also received. Now, but what happened then? In one of the retrospection, I was looking into the data, and I realized that most of the contracts are actually getting renewed. So the failures are limited. I mean, the negative cases where the renewal is not happening are very, very limited. So close to 96-97% contracts were renewed. So when we started having conversation, and we said that okay, even if our models say yes to all the contracts, then also it is 96% accurate. It is better than the model that we have created. Shouldn't we challenge the accuracy? But again, there were different ways to look at it. How accurate it is able to identify the contracts which actually were not, which are predicted they will not get renewed, and they also did not get renewed. That was the indicator to qualify whether the model is accurate or not. So when you go into these implementation, you will realize okay, and it is also completely business driven how they look into it. So I picked up another example where I was talking about the suicidal tendencies. Again, if you're looking for one of these scores, mean square, they it is if it is 5% off, 10% off. Uh, the community for whom you are actually building this model, they will decide whether it is good enough or not, right? uh, we so obviously when you are building the models, sorry, please go ahead.
Yeah, so the example you quoted, right, the Microsoft renewal one. So can we consider that as a classification model?
Yeah, correct. That was the classification one. Visu, you have a follow-up question?
No, sir, I'm good.
Okay. Yeah. So again, in case if we had predicted the uh, contract value, uh, what will be the renewal value, right? That would have been considered as a regression one.
Regression.
But if it is, yeah, if it is yes and no, or maybe, right? Even then, it is a category because these are three different separate categories that we are dealing with. Now, overfitting and underfitting. So obviously when you're dealing with such a complex case, lot many times we spoke about that the model accuracy. We also spoke about the cleaning and other activities that you are supposed to do. Now, what actually happens in overfitting and underfitting? These are the two things which happens very often. Overfitting is a case where the training data is giving you a very high accuracy. Maybe the data that is given to you, maybe it is giving 90%, 95% something, right? Whereas you put it into the production, and when the production data is actually fed into these models, the accuracy drops. Say it drops to 70%. So what is happening here? Maybe the data that was supplied to the algorithms, it kind of overtrained itself. So it actually kind of fitted into that particular bracket. And how it happens, we will talk about it separately, right? With some examples. But this is a case where actually you have got n number of rows and n number of features, and somehow you have actually fitted that into the model. But the moment it actually reached the market with the real data, it kind of faltered. It kind of failed. So this is where the overfitting comes into the picture. And then there is underfitting. Underfitting is actually it shows a poor output even in the training set. So in a way, you probably will need more features to overcome underfitting. Underfitting will not, most of the times it should not make it to the production. So these are the challenges that you will face. But once model evaluation is done, what is required is that you will deploy the model into production, and then you have to retrain, and model improvement needs to take place. So see, you when you were training the model, maybe there were 10,000 rows, but now you have put it into the system, and there are 5,000 transactions more that have happened. So you will go ahead and retrain your model. That's how it should be done. So you have to define a frequency when you will collate the data, and you will go back and try to retrain it, so it actually adjusts and do a better prediction, right? And this is the pictorial representation, how it works. It starts with data collection, data cleaning. You split the data into two parts: train and test. You identify or choose an algorithm. You can also do this. You can augment or you can club multiple algorithms together. That is also allowed. I mean, the system actually will let you do that. It is not about whether it is allowed or not. So as it is completely up to you as a data scientist, if you want to put two different algorithms in sequence or maybe parallel, you can do that. And ideally, actually, should be done when you're doing this such kind of experiment. You can bring two different algorithms and take advantage of it. So once that algorithm has been chosen, you train the model, evaluate the model, check for overfitting and underfitting, and retrain. So this is the overall cycle. Okay, let me pause here again. Let's discuss. Let's uh, take up the questions.
So one question related to this steps, right? Model evaluation and underfitting and overfitting. So all these are not both. I mean, both these steps are same, or they'll be considered as different in the actual model building.
Yeah, so they are. See, these logically they are different, uh, and but if you look at it, let me share this screen again. So these are more of logical, but when you are working on these, the moment you are done with splitting of data, maybe naturally it will come to you. Oh, okay, I will go with this particular algorithm. Training the model, you will not even consider, because that is a part and parcel. Then overfitting and underfitting is something that maybe consider the QA work here, and the QA particularly will be dealing with overfitting and underfitting, because when all these steps up till evaluation of the model, it already would have been done by the folks who are writing the models. So now it is in the production, right? And now how the model is behaving, that is where the overfitting and underfitting comes into the picture. Remember that
Can we say that? Can we say that it is a user acceptance test kind of thing? I mean, when you consider correlate with functional thing.
uh, you can say that. You can say that. It is only that the only difference, whether it is you bring that data at a QA level, user acceptance level, or in the production. The difference here is the data that you have used to train the model, and now the data that you are pushing into the system is different, right? So in case if you have some other data which actually has not been given to the model development, right, and you have kept it for your own acceptance, definitely it can actually take place at a QA level, it can take place at the user acceptance. So there is no differentiation here, no boundary. Any other question? If we have understood this to a very large extent, you have understood what actually data scientists do. And one important part here is the algorithms are already defined. What we are going to do is to pick up the right algorithm and experiment. Even that is something which you can pick up multiple algorithms, and when you are in the testing phase, I mean what the AI developer is doing, right? It can experiment with multiple algorithms. That also is possible. So in case if you have understood this to a very large extent, you have understood how machine learning works. So this is definitely a very important step. Now, what we can do, we actually can look into how this is being applied using Python, right? Maybe in the subsequent class, I will pick up another tool, which is no code tool, and using drag and drop, we'll try to implement these models. But in today's conversation, let's bring up uh, uh, how it can actually be solved using Python. I have some examples. Just give me a second. Let me bring it up. Yeah. Okay. I hope you can see my screen.
Yeah.
Yes, sir.
So some of the material which we were working on in Python, and visualization and sklearn is something that theoretical part is not done yet. We'll go back after this class. I mean, of course, in the next subsequent session, uh, and we'll work on those modules. We'll spend some time onto it. But you have understood what is pandas, numpy, right? Now we are dealing with sklearn, and sklearn is one of those libraries where most of the algorithms are actually defined. Then we have got matplotlib. So here we are bringing all these libraries, and then sklearn also has got some inbuilt data. And here we are picking up the housing data. So housing data has been picked, right? And then we are doing some kind of data exploration. I'm giving you at a very high level. I'll go into the data and show you how actually it exists, so that it gives you a better understanding. We are trying to understand how the data is looking like, right? So it has got different some of these columns where we have got what is the median income of that particular region, of that particular uh, area, right? What is the age of the house, average room number of rooms, average bedrooms, right? What is the total population and all. In that particular region, what is the average occupancy, right? And then the latitude and longitude, this is the location. And then house value, that's again a median one, but this is what we are going to predict, right? So why it is regression?
We are dealing with numerical values.
Correct, correct. So what we are trying to do is to predict
Right.
the house value, right? Then we do some data cleaning. It is done in a very lame way. So, but it is far more extensive when we will do it in some of the examples. So here, what we have done, we have identified whether there is any null value in any of the columns. So the data is good. There are no nulls, right? And then we are trying to uh, split the data into training and test set. So the test size has been defined as 20 0.2. Sorry for this. Yeah. So the test size 0.2 here means 20%, and 80% of course has been given to the other side. So this is how you are splitting. Uh, then once the data has been split, you are calling two different. Sorry. So you are calling two different algorithms. One is linear regression, another is decision tree. And look at the number of lines that you have to code. That's it. So why so? Because uh, these algorithms are already defined. They're already defined in sklearn. All you need to do is to access them, implement, and pass the data. That's all, right? And then once uh, uh, the training is done, you need to predict. So for that, you are passing the test data, and then you're finding the accuracy. I have gone ahead and implemented some. Yeah, so this is where you are actually picking up the data. You're doing the prediction with the new data sets, and of course there is a decision which has been formed. I actually had executed this, so it is in a way it is also containing the results. So if I look at this, I'll provide this Python file to you so that you can also experiment with it. You may have to install sklearn in case if it is not already there in your system. So if you look at it, um, the two different scores that has been calculated here, r square, this is a score, 57% something, and mean square. So that is 74 something, right? And there are two different algorithms that were applied. So one was linear, another was decision tree. So if you look at it, this is how it was applied, right? This is the training. So I mean, the when you actually split it the data into two parts that you are passing to the model for training, and the same thing you are doing for the decision tree as well, and then you're testing it against the test set, and you have the prediction output. And also when we are giving the new data set to the models, right? Uh, uh, Now you are actually dealing with the object of the model that has been created. So it is predicting that, okay, in case if you have given these numbers to a linear regression one, it is predicting 4.159. So you can assume that this is in millions. So it is predicting it is the house price is going to be around 4.1 million something. And if you are giving it to the decision tree, it is 3.8 something. Now, whether when you are doing this kind of prediction, uh, you want to go with linear or you want to go with a decision tree, right? Uh, as a data scientist, you should have a clear understanding on that. Linear regression is just too simple. So it is good to understand the concept, because linear equations you would have studied in school, colleges, uh, but it is too simple to be true. That's not how the system works, right? We will talk about them in the subsequent classes as well. What is the real situation, right? Not It is not the linear one. So as a data scientist, it is not possible. Not possible. I'm not saying that is highly unlikely. It is not possible that you will actually go ahead and implement linear regression. If a particular problem can be solved through linear regression, it will not come to you for sure. Uh, so you have to apply different techniques. And decision tree and random forest, which I was referring to, is an implementation of decision tree, very extensively used one. So when you are when you have to take a call between these two, maybe I will be tempted that though the accuracy rate is very low, but I know that linear will not work. Just for the experiment's sake, or maybe uh, defining the lower threshold, I have used linear one, but I was not serious when I was actually applying it. I just did it for fun. I mean, you can go to that extent. Linear are not going to use. So as a data scientist, I will definitely choose this decision tree over linear one, despite their scores are inferior. Again, this kind of understanding you will develop over a period of time. You cannot actually scale the mountain in a single go. We will take some baby steps. Uh, so this is, I mean, I just wanted to show you how things are working out, right? How you pick up the data, then how you try to analyze, you take right kind of decisions, you try to understand, okay, what kind of pre-processing steps are required, uh, uh, how you will eliminate the erroneous data, right? And what are the different algorithms that you can apply. So this will give you a reflection of why Python is important, right? And to what extent actually you should be learning. It is not that you need to learn Python in and out, but to deal with this kind of data, right? Bringing these algorithms together, doing all this kind of prediction, you will need hands-on knowledge of Python, right? But to this extent only. You don't have to become a master. But again, even to reach to this level, you cannot actually call out that it's a very basic. A bit advanced, definitely you have to deal with. And then dealing with the data, which is kind of uh, the which will form the engine. Uh, so how you deal with the data. So that's where the SQL part will come into the picture. Uh, yeah. So that is what I wanted to cover, and make sure that you understand the different components that we are trying to bring in, why they are important, right? But somebody who already understand how Python works, somebody who already understand how data works, right? Actually, they can start from here itself. They don't have to go back. You're good to go into the next step. So this is what I wanted to cover. I can take up more questions.
One question, sir. So related to overfitting or overfitting under 15 steps.
Sorry.
So there is a step called overfitting or underfitting of data or model.
Yeah.
So can we think the underfitting what is a case use case? Can we think is that due to wrong selection of algorithm? Because it is not even working with data, training data.
It it can happen so. Okay. Yeah. Sorry. Yeah. It can happen so. Typically, what happens, Vishu, when you are dealing with a decisions tree in particular, they tend to overfit themselves. And so that's a good question. I have more appreciation of this question now. Uh, so when you are dealing with decision tree in particular, and there can be many more examples. Also. Uh, so a decision tree is known that, okay, when you are supplying some data, it will form branches, right, and try to reach to the leaf node. Though in this training, what we are going to cover, we will have a separate conversation specifically dedicated on decision tree. But since some of you already know how decision tree works, so it is going to, there will be a split that will happen at every step, right? Yes, no, some kind of decision making will happen, and you will finally reach to the output. So when you are actually giving the data to the decision tree, it has got a tendency that it will overfit. So the output is going to be uh, uh, too good to be true. But in the real situation, that may not happen. And that's where a different technique comes into the picture, which is called pruning, right? So as a data scientist, again, the more time you spend into this particular domain, into this role, you will realize that, okay, these are the kind of challenges that you will face, right? And these are the possible measures to make sure that such kind of issues are not being uh, I mean, they are being addressed at the right time itself. So pruning, generally what it does, it actually reduces unnecessary branching of decision trees. So in a way, it actually kind of avoid the model to overfit itself.
Okay.
So you are right from that context. In case if somebody has used a decision tree and it is giving too good output and it fails in the production, right? You can qualify it as that it is underfitting and the algorithm that has been chosen is not the right one.
Got it. Yeah.
That's a good question, Vishnu. Yeah. Any other question? So one of the point that I wanted to share, that I know that I have ran through the Python script very quickly, but the idea was not to let you dwell into the Python code too much. Idea was just to let you know that, okay, how things are actually working out, how you as a data scientist are supposed to handle the different pockets. I will, in any case, I will share you this Python file, right? You can go ahead and execute it at your end. Try to troubleshoot, because it's a self-contained piece of code where the data is also embedded into the algorithm that you are going to apply. So there is no dependency as such. Deploy it into onto your local folder and execute, and see what kind of changes you can do, what kind of experimentation you can do, and how you can actually improve the quality of the output, how you can reduce the error. Okay, so that is like, in case if you do not have a question, I would like to stop here. But can I get an acknowledgement before we drop that? Did you find this piece of conversation much more relevant? All right.
Yes, sir. But
All right.
somehow we'll
Yeah.
practice at our end that learning things will be it will convert in a very good phase once we do at our end. So
Yeah.
we will also keep putting our effort so that we can raise the questions with you regarding the topics which we are covering.
Sure, sure.
Right.
Yeah. Sure. So I think yeah, absolutely. You need to spend just to make sure that you are at the right pace with the training that we are undergoing. Maybe you can assume that it is like you have to spend 5 to 6 hours on a weekly basis to make sure that you're grasping the content, right? The concepts, and that may not be good enough for you to actually get into the industry and practice next level. So you have to spend more and more time, maybe another 3 months once the course is done, 3 to 6 months. Uh, but taking up different use cases, implementing them, and seeing that okay, how is that knowledge being worked out, and also continuously talk to the people who are already in this industry and working on different use cases. So please extend your circle. Try to connect with those who are the practitioners. Or
Sure.
maybe, yeah, or maybe you have to study a lot of articles to get that understanding.
Sure.
All right, if that is the case, we can stop now, and I'll meet you in the next week, and I will let you know what we are going to cover and the scope of the next session. All right, thank you so much. You have a good day. Thank you.
Thank you, sir. You too.
Thank you.
Thank you, Arun. Thanks, guys.